Hi viewers, you are welcome to another episode of Staad Pro. In this episode, I will be designing this one-story building using the RC designer. In the previous video, we've modeled, loaded and analyzed this building. So if this is the first video you are seeing, then you need to check the previous video. Okay, so now we are going to transfer this to the RC designer. The RC designer is one of the designer you can use to design a building in Staad Pro. Okay, so but before we do that, you need to go to the general tab and then you go to load and definition. Then you come to load envelope, then you add a particular load envelope. All of this, just send it here, just send everything here, and then under the type you can click strength. Okay, so load envelope is usually numbered. You can have number 1, number 2. You cannot give it a particular name, so let me just give that and click on add. Okay, then you close that. So in the last video I should have shown you how you can check your stress, but I will show you now. So we need to analyze this again, because doing that, adding the envelope will have disrupted our analysis, so we have to reanalyze. No, I want to abort. Okay, I aborted that because I need to use the ultimate limit state. So let me reanalyze. Okay, so let's go to the post processing and then just click on OK. So let's check the stress, the plate stress. So you go to the plate stress. This is the beam stress. I'm not interested in the stress of the beam, I'm interested in the stress of the plate. So click on plate stress, then I'll be using the ultimate limit states, and then I can check the maximum absolute. You have many, you can have the vertices and many. So I'll be checking this one and I just click on apply. Okay, so this will show you the stress. You can see how the plate is being stressed. Okay, so when you look closely, you can check the legend you have here, the color legend. You can see whenever you have a brown color, it tells you that the stress there is equal or less than 0.084 newton per mm square, and the maximum is at the bottom where you have 0.391. so it means anything you see in red here is actually equals or greater than 0.391. Okay, so that is the purpose of the meshing. If you remember, when we're still meshing, when I use the this one, which is the generate surface meshing, so that's the purpose of meshing. Okay, so if that is done, then we can transfer this to RC designer. So you just click on concrete design. So this is the RC designer. When you look up here, you can see Staad Pro RC designer. So when you say we want to design with RC designer, this is what we mean. Okay, so the first step when you are using the RC designer is to create the envelope, and that is what you can do in Staad Pro. You can see that's what I did in Staad Pro, and then I run the analysis. So after you are done doing that and you've transferred it to Staad Pro, the next thing you should do is you need to form the column into a member, and you also need to form the beam into a member. Actually this column is an element, so we need to turn it from element into member. The beam is also an element. You need to turn it from element into a member. All of this you are seeing, they are plates. At the top they are plates. You need to transform them to slab. So from plates to slab, from element to member. Okay, so let's do that. To do that, you have actually two methods. You can select your column like this. Let's select column and select column. Then you go to member and click on form member. Then this top column and the bottom column has been formed into one member. Okay, you can select this as well, and then this. Then you go to member, you say form member, select this, and then you select this. And then select this, then you click on member, you say form member, but that will take you a lot of time. Okay, for example, you go to select and you say member. Let me select this. You can see this is a single member. Now select this is a single member, select this is a single member. Okay, however, this will not even select because it's not a member yet, it is still an element. So but that will take me a lot of time when I'm just creating the top and bottom forming member. So what I can just do is let's put it in front view and then select all of the column. No, I don't need to select that. I can just select this and select this. I've turned this one to member already, so you can put it in 3D view. Then I'm going to go to member, then you see Autoform member. when you click on Autoform member, it's going to automatically turn all of them into member. However, it may not join the top and bottom. It may not join them, and it may join them. It depends on how it wants to do it. Okay, so the best thing for you to do is to form the member or your own. When you use the auto form, it will disrupt it. It's not like it will give you a wrong design. Of course, it's not give you a wrong design, but you have a lot of members. It will not group it the way you want to group it. Okay, so I prefer using the form member, but when you use auto form, it will just form it the way it wants. So let's click on it. There you can see, let's see, for example, see, do you notice M1, M2, M3? Now look at where M20 is. Okay, look at where M13 is. You see, that's what I was trying to say. Look at where M10 is. Okay, so but I think the maximum is M27. Okay, maximum is M27. So let's do the same thing for the beam. Let's put it in front view and then select all of the beam, and then select this one to Alt Control. Let's put it back in this, and then we're going to use the auto form member again. So it has formed all of that, so that is very good. So we also need to form slab. We need to form the plate into slab. So you can go to select and I pick plates. Let me check, let me use the front view. So when you select the plates, you just select this portion. Let me just select this portion, then you go to slab, click on form slab. Okay, then select this small portion again. No, just this small portion, then click on form slab. Here, form slab, you can do more. Form slab, form slab, form slab, and then here form slab. Okay, so let's put it back in isometric. Okay, so now that we've turned all of the plates into slab and we've turned all of the elements into member, the next thing to do now is to create brief. Okay, so you create group brief. So you go here, which is group or brief, then you are going to start with the brief. Let's start with the beam. The first one is beam, and make sure this is in beam. You can check your code here, then click on OK. Then you are going to make some corrections you want to make. So for the beam, I want the cover to be 25, the minimum for the top and for the bottom, and also for the side I want everything to be 25. The maximum aggregate size, that should be 20, and the grade I want to do is to be 25. And then the envelope is 1. Then I can design for torsion. Main reinforcement, I want the minimum to be 16, I want the maximum to be 25, and then the link or angle, that should be 10. This 16, the same thing, 25, and then here I want it to be 10. All right, and then the main bar, I need 460. Here the minimum should be 10 for the for the sidebar. Sidebar is what we call runner. I prefer to use 12 mm. Then you can go to the shear reinforcements, and then you can change this to, let's just leave this in 8, 2 numbers, and then the link I can use 250 for link. Okay, and then this should be closed. Just click on OK. So you can create another brief for the column. Then change this to column and then click on OK. Then your column, I'll be using 25 size 30. The cover of 30 is enough. The maximum aggregate size of 20. I'll prefer 460. Here the link, I'll prefer 250. The minimum size for the member, 16. The maximum size, let me use 20 for the column. Then the link, 8 is enough. Column factor, just leave everything as it is. And here, transfer everything here. Click on OK. Then you can do for the slab too. Click on new brief and then change this to slab. Then give it a name. Call it slab. Okay, and then just leave this as VT10. Click on OK. For the slab, I'll prefer the cover to be 20. The cover should be 20 here too. Then the maximum aggregate size, that should be 12.5 mm. This I'll prefer this, and then go to the main reinforcement, change this to 460, and then here 12 mm, 12 mm, 12 mm, and then 12 mm, then click on OK. So that is good. Then we can now create design group. Now to create the design group, the first thing you need to do is you need to select all of the member. For example, let me create a design group for the column. You see that the column start from M1 up to the last one, which is M27. So I'll go to select. I'm going to select by member. I'm going to select member 1 up till member 27. Okay, so that is the column. So click on OK. You can see all of the columns have been selected. That's good. Then you click on new design group. So everything you've selected here will form the column. So I'm going to say this is column. So let me call it column design. Then change this to column. Okay, then click on OK. So that's very good. So you can see this everything under it. Now another thing you can do is you select the remaining. You know the last one is 27, so the next one should be for the beam, that should be 28 up to the last one. So click on select and you click on by member. Then I'm going to select from 28 downwards, so this is 28, then select to the last one, which is 43, then click on OK. You can see that all of the beams have been selected. Then you're going to create, then you click on new design group, and then let this be beam design. Then this should be in beam. Okay, click on OK. All right, so when you double click on this, you see that all of the beam are under here. So that's good. The next thing now should be for the slab. So you can come to this tab here where you have the slab. So click on new design, and then here you don't need to be changing the name, just keep just need to be changing for the last one, which is for the slab. So we have about 8 slabs together, so let's start doing for them one by one. This, the next one, this, the next one, that should be 3. All right, this 4, the next 5, then we go more 6, one more time 7, and then for the last time that is 8. So we've create a group for all of the slab too. So now all we just need to do is design. Okay, so you should just know the steps. We just need to design now. So to design, you can go to concrete member, so let's start with the column. So go to design, and then you go to design now, and then you click on OK. Then you can see everything here is okay. So everything has been designed successfully. So when you look closely, you see that all of the column are in green color. All of the columns are in green color. If they didn't pass, if there is any that didn't pass, you definitely see it in red color. Okay, you definitely see it in red color. So all of the column pass. Let's see for the beam. Just click this drop down, pick the beam. Then you go to design. I'm not clicking the design option. Design option will allow you to select everything. It's still the same thing. You can do like, let me just click on design now. So design everything at once. I click on OK. Then let's see everything. Okay. Everything passed. So you can see everything in green color. You may not see it properly, but when you zoom in, you see that all of the beams are in green color. So we move to the slab. So you go to slab. Let's design the first slab, which is slab design 1. Before I create the design, before I design the slab, you can see everything here, no any. This simply means not available. That is, the main steel is not available. Okay, but before I start doing that, I would like to create regions. So go to region, and then click on draw region. So I'll draw region like this from here to here. That should be one region. Okay, so I'm trying to create a region. The way I measured it is the way I'm trying to draw the region. You may not draw your region the way I'm drawing it. The purpose of drawing the region is to make it more more concise. Okay, so that you can know perfectly the kind of reinforcement you have at that region. As small as it is, you will know the reinforcement. Okay, so I have this kind of region. Then you can see everything here not available. Even the spacing, you can see even the spacing is not available. So let's try to design and see. Click on design. Okay, so 50 of 50 have been okay. Thank you. So you can now see that okay, the moment, these are the values of the moments, and you can see why. you have T12 all through, and you have this one, you can see 350 spacing, 300 spacing, 350 spacing. So these are the spacing of your slab. You can see you even have a very high spacing, 350. So that is a very good result. You know, had it been you're having something like 150, then you know you are in trouble, because that is, you know, it is very close to failure. You know, but this is very, you know, you have a very high chance. So this is basically how you keep on doing it. So you can keep on doing the slab too. You can draw region for this, and then you do the same thing. But let me go back to the beam. Let me go back to the column. Then you can check the detail of the column. Go to the main layouts. So this is the layout of the column. So you can see this is the boundary, and these are the reinforcements. You have 6 numbers of reinforcement. Okay, so this you are seeing here is the bending moment diagram. So you can see, and then if you want to you know, check the table for your shear, you know, you can check it here, and then you can also come here to check your shear layouts. Check your shear layout. So this is your shear. So you can see this line that represents the boundary, okay, of the concrete, and this one, that is your shear, which is your link, and then you can see your reinforcement. So when you just click on the reinforcement, it will give you can see T16, and then when you click on that, you can see T16. So that's how you, that is very easy, you can see. So you can go to beam. Let's go to beam. No, beam. So under the beam, you can also check the main reinforcement. This is what you see in the main reinforcement. It will tell you the area at the top. Yes, required. Yes, provided. And when you go to the layouts, this is the layout of your beam. This is how the layout looks like. You can see here you have the support reinforcement. Here you have the span reinforcement. At this point, you have a support reinforcement. So, and you can see where the section is being taken. This section is being taken at what? 1.25 meter. If you want to take the section upward, let's say you want to take it about, let's say 0.3 meter. Click on set. You can see this is where the section is now. So at that point, you can see the section is cutting through the supports and cutting through the span. So if you look at your section here, you can see you have 2 at the top, you have 2 at the bottom. Okay, so to know that, you can just put your cursor here. You can see T16, also this T16, this T16, this T16. Okay, so everything is 16 mm. So that's how you can see that. And then how about you transfer it to AutoCAD? You can definitely do that. So you can just come to drawing, and then this is the drawing. So if you want it on A2 or A3 or A1 or whatever, just put it there. Okay, and then the scale, you can adjust the scale. The title block, where do you want the title block to be? Should it be at the right or should it be at the bottom? You can see, let it be at the bottom. So, and then you can also cut span. That is, you just cut a particular span and then you section. Let's see, span 1. You can see the span 1 at the top here. Span 2, you can see, you know, that's through everything. Then you can come here, which is DXF. So you can export as DXF or you export as multi-rebar. Okay, so that is how you do that. So if you want to do that, just click on OK, but I'm not doing that, I'll just close that. So that is just how you do that. If you like this video, ensure you leave a like behind and make sure you subscribe to my YouTube channel if you haven't subscribed. Thanks for watching, and watch out for the next episode.